Hello friends, this is Rohit from careerdost.in. Welcome to our YouTube channel Career Dost. So this is the second part of the permutation video series. In the first part we have already discussed definition, formulas, basic examples in permutation, factorial table to memorize. Then we discussed first type of permutation. First type was numbers, in which we discussed non-zero type and zero type permutation problems. Then we discussed second type of permutation. Second type was words, in which we discussed non-repeated letters and repeated letters. Now in this part we will discuss the remaining word type permutation problems. So let's start with the second type of permutation problem in words. So second type is repetition allowed and repetition not allowed. So let's take an example. So the question is the same, how many types of word can be arranged. So let's first try to understand what it means when we say repeated letters and non-repeated letters. So RNA is repetition not allowed and RA is repetition allowed. So let's use a word AB. So how many ways AB can be arranged? So we will just compare it when repetition is not allowed and when repetition is allowed. So when repetition is not allowed, so we can arrange AB in two ways. So one is AB and second is BA. So we can simply say it's 2 factorial. But when we say the repetition is allowed, so what does that mean? So AB and BA will definitely be there. The only addition will be repetition is allowed, so we can use A again and B again. So AA and BB will be added here. This is for when repetition is allowed. So what we do here is we will take the letters are 2 and the repetition which is allowed is also 2. So square of that number. So when we say repetition not allowed, AB can be arranged in two ways. So that is 2 factorial. But when we say that repetition is allowed, in this case A can be repeated twice and B can be repeated twice as well. So here we have 4 ways. So here we can say that AB can be arranged in 4 different ways. So we can make a simple relation here, 2 square. 2 will be the number of times we have the repetition. So it will be better understood with the help of an example. So let's see, we have 3 words, dog, coin and aptitude, the same words that we used before. So as we know, when repetition is not allowed, count the letter of dog and we will put it like 3 factorial. Similarly, in the case of coin, it will be 4 factorial. But when repetition is allowed, so we have already found a simple relation. In the case of repetition allowed, when the repetition is allowed, it will make 3 to the power of 3. In the case of coin, it will be 4 to the power 4. Now what happens when we have aptitude? So this is a case in which T is repeating. So in case of repetition not allowed, count the number of letters, that is 8 factorial divided by the number of times the letter is repeated. So that is T is repeated twice, so hence 2 factorial. In case of when repetition is allowed, what we will do here is 8 to the power 8 divided by 2 factorial. Why? Because this is when repetition is allowed. For example, if we have to solve it for Philippines, the case will be same, like Philippines has 11 characters. So 11 to the power 11 divided by 3 factorial into 3 factorial, because P and I is repeated thrice. Remember, when in case of using repetition is allowed, then only we will use the power. I hope you understood this concept. So let's move ahead to another type, that is always together. So in this section we will deal with always together type of problems. In always together we have 3 types, which are when we have vowels together, consonants together and other words together. So first let's start with vowels always together. So the question is, how many words can be formed when vowels are always together? See, these vowels are always together. So we will use the same example. One is coin, another is aptitude. So let's first talk about coin. So here we know that vowels are O and I. O and I are the vowels here, and the rest of the letters are C and N. So how many places O and I can be placed? So this is first place, second place and third place. Remember, these vowels have to be placed together. So there will be 3 places. So they are saying O and I should always be together. They are not saying where it should be. So what are the various places in which it can be arranged is 3 places. So this is 3 factorial. And what is the probability between O and I? O and I can be arranged in 2 different ways. So the answer to this is 3 factorial into 2 factorial ways. Similarly, in the case of aptitude, we know that vowels are A, I, U, E, 4 vowels, and the remaining letters are P, T, T, D. So the vowels can be placed here, 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 here or here. So we have 5 total places. So So we can say it can be placed in 5 factorial ways. But the catch here is the t is repeated twice. So what we will do, as we have already discussed it before, it will be 5 factorial divided by the word that is repeated. So divided by 2 into vowels. Vowels can be placed in 4 different ways. So into 4. So 5 factorial divided by 2 factorial into 4 factorial. This is the answer. So this is for vowels. Now let's see for consonants. So the question is same, how many words can be formed? Only difference is consonants are always together. So we will take the same example, coin and aptitude. So the only difference here will be, we will be using consonants in place of vowels as we used in the earlier example. So here what we mean is, consonants here are C and N, and we can place it just like we did earlier. The leftover words are O and I, and we can place it in 3 different places. So we can very easily say that 3 factorial into 2 factorial, because C and N can be arranged in 2 different ways. So 3 factorial into 2 factorial. In case of aptitude, here the consonants will be P, T, T and D, and the ways it can be put will be again 5. So it can be placed here, 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 here or here. So what will we do? As we know that 5 factorial, there are no repetition here. So 5 factorial into 4 divided by 2, because t is repeated twice. So this will be the answer when the consonants are always together. So similar type of problems can come from other words also. So what we mean by other words is, they give you a question. Let's take in aptitude word AP is always together or PT is always together. So whenever always together comes, club those letters together, put them in the bracket, and remaining letters you can write it separately and fill the spaces. So that's how we do it for other words when asked always together. So now we have dealt with 3 types of problems in always together, which is with vowels, consonants and other words. Next concept that we are going to deal with is never together with the similar vowels, consonants and other words. So in the previous concept we deal with always together with 3 respective vowels, consonant and other words. Similarly we have got 3 types in never together. So let's first see when the vowels are never together. Question is, how many words can be formed when vowels are never together? So here is a formula which says total number of ways minus always together. So let's take an example. Example is coin and aptitude. So vowels are never together, and here the vowels has been O and I. So the formula here is total number of ways minus always together. So total number of ways in which the words can be formed will be 4 different ways, so 4 factorial. Now let's say when the vowels are never together, the leftover words or consonants you can say are C and N, and it can be placed in 3 different places. 3 factorial into 2 factorial. So 3 places and 2 vowels. So that's how we know always together, as we were doing earlier. Only difference here is that we will just subtract it from the total number of ways. So the answer will be 4 factorial minus 3 factorial into 2 factorial. So this is how we do when it's never together. Once you will solve it, you will get the answer. Let's take it for aptitude. So vowels here, as we know, A, I, U and E. So total number of ways here will be 8 factorial divided by 2 factorial. The remaining words are P, T, T, D, and the number of ways it can be arranged is 5. 5 spaces it can be arranged. So always together will be 5 factorial divided by 2 factorial into 4 factorial for vowels. Now we will subtract this from this. That is total number of ways minus always together. So once you solve this, you will get the answer. So this is for vowels. Let's see for consonants now. We will just change the vowels to consonants. So consonants will be CN, and total number of ways will be same 4, and the remaining letters will be O and I, and always together will give you 3 factorial into 2 factorial, and the answer will be 4 factorial minus 3 factorial into 2 factorial. In case of aptitude, it will be consonants will be P, T, T, D. Total number of ways it can be arranged will be 8 factorial by 2 factorial. The remaining letters would be A, I, U and E. So always together will be 5 factorial into 4 factorial by 2 factorial, because T is used twice. So now what we'll do, total number of ways minus always together. So this will be the answer for consonants. In case of other words, for aptitude they can say that, let's say AP can never be together, or TU or UD can never be together. In that case you will follow the similar way in how we did it for vowels and consonants. So I hope this is clear. So now let's move ahead. In this section we will deal with the fifth type of words problem in permutation category. So fifth type of permutation problem is odd and even places. So the question is, in how many ways the word detail can be arranged in such a way that vowels occupy only odd position? So detail is the word. So let's just write it. DETAIL. So 1, 2, 3, 4, 5, 6 letters. Vowels occupy only odd positions. So vowels here are E, A and I. And odd positions here is 1, 3 and 5. So the permutation will be 3P3. So we have 3 odd position and we also have 3 vowels. So now the remaining letters are D, T and L. So it can be arranged in 3 factorial ways. So the answer to this question would be 3P3 into 3 factorial. So once you solve this, you will know in how many ways the word detail can be arranged in such a manner that the vowels occupy only the odd position. Let's see another example. So let's see when it is for even position. So the question is, in how many ways the word aptitude can be arranged in such a way that vowels occupy only even position. So first let's write aptitude. So aptitude has 8 letters. Now they are asking for even position. Let's first separate out vowels and even position. So as we know that vowels are A, I, U and E, and even position are 2, 4, 6 and 8. So it will be 4P4. Now the rest of the letters are P, T, T, D. So 4 factorial divided by 2 factorial because T is repeating twice. So the answer to this question would be 4P4 into 4 factorial divided by 2 factorial. So once you solve it, you will get the answer. So similar type of problems can be for consonants and other words as well. So if there is consonants there, instead of clubbing the vowels, we will club the consonants together and follow the same procedure as we did it here for vowels. So this is the concept for odd and even places. So let's talk about the last concept, which is no two together. So the next and also the last concept we will be looking is no two together. So in case of no two together, like we did for previous concept, we will deal with vowels, consonants and other words. So the question here is, in how many ways the word detail and fridge can be arranged in such a way that no two vowels are together. Let's first talk about vowels. In the similar way it can be consonants and other words. So in case of no two vowels together, so first let's write the vowels together. So we have E, A and I as 3 vowels here, and these are the remaining letters. So it will give us 5P3. So we have 5 places, out of which 3 needs to be arranged at different places into 3 factorial. So these are the remaining letters. In case of fridge, the vowels are I and E. So the rest of the letters are F, R, D, G. So we have 5 places. We have to arrange 2 vowels. So 5P2 into remaining letters are 4. So into 4 factorial. So once you solve these, you will know how many ways the word detail and the word fridge can be arranged in such a way that no 2 vowels are together. So similar type of problems can come with consonants and other letters. In case of other letters, as I have told you earlier, they can ask D and E can never be together, or T and A can never be together. We will follow the same method as we dealt with vowels when no two are together. So with this, we come to the end of the second part of the permutation video series. Let's just recap what we discussed in this video. So we have started this video with the second type of permutation problems in words, which is repetition allowed and repetition not allowed. After that we discussed third type of word permutation, which is always together, and we have seen when the vowels, consonants and other words are always together. After that we discussed fourth type of word permutation, which is never together, and we have also seen all the 3 cases while dealing with vowels, consonants and other words. Then we discussed the fifth type of word permutation, which is odd and even places for vowels, consonants and other words. And lastly we discussed sixth type of word permutation, which is no two together for vowels, consonants and other words. So if you are thorough with all the 8 types of permutation concept, I'm pretty sure you can crack permutation section of aptitude exam very easily. So hope you like the video. If you do, please don't forget to like and share the video and subscribe to our YouTube channel. We will be making similar videos in aptitude category. Thank you.